Hi everyone, my name is Alasdair and today I'm going to give you a tour of AttentionFlow, a demo that can visualize a network of time series. This work is done by my colleagues and I at the Computational Media Lab at the Australian National University. In this demo, we are interested in visualizing how influence propagates in a network of time series. In particular, we're going to visualize two real-world datasets, the recommendation network on YouTube and the hyperlink network on Wikipedia. So let me just focus on the YouTube network. In this particular example, we can see the recommendation network centered around the music video Rolling in the Deep by Adele. We call this node here the ego node. Now, all the other nodes on this page are connected to the ego node, meaning that there's traffic flowing from the neighboring nodes to the ego node. And these edges are determined by YouTube's recommendation algorithm. So when we constructed this dataset, we added an edge from, let's say, counting stars to rolling in the deep, because rolling in the deep appears on the recommendation sidebar on the YouTube page of counting stars. In addition, the thickness of an edge corresponds to the amount of traffic or the amount of influence flowing from a neighboring node to the ego node. Here we can see that there's a lot of traffic going from someone like you to rolling in the deep, but just a little bit of traffic going from counting stars to rolling in the deep. If we hover over a node, we can see an actual estimate of the traffic flow. For example, here, about 347 million people clicked on rolling in the deep after they had watched someone like you. These estimates, by the way, are not provided by YouTube, but they come from a regression model from prior work in our lab. So please check out our paper if you are interested to see how these numbers came about. So hopefully by now you would have a good understanding of what each node and each edge in this network means. Let me next talk about how to visualize the actual time series. So on the top panel, we can see the blue line chart showing the daily traffic of the ego node. In addition, we also offer a tree ring representation of the same time series inside each node. This is the more coarse-grained view of the time series, and it allows us to quickly compare the evolution of many time series at the same time. Specifically, inside each node, we can see that there are many rings, each of which has a different color. Each ring corresponds to a particular year, and the size of each ring corresponds to the total amount of traffic accumulated in that year. For example, if we look at the tree ring for hello, we can see that the video gets most of its traffic in the first 2 years, as indicated by how most of the area is occupied by the two innermost rings. In contrast, for counting stars, the traffic is fairly evenly distributed among all the years. Finally, on the top panel, we also mark external events that could have an influence on the traffic. For example, when we hover over the first peak here, we can see that that peak coincides with the Grammy Awards in 2012, during which Adele received 3 Grammys. And that was the external event that led people to go to YouTube and listen to Rolling in the Deep. Now you might wonder, what about the other surge in traffic around the end of 2015? Well, if we hover over Hello, we can see that that surge coincides with the release of the song Hello. This, coupled with a very thick edge from Hello to Rolling in the Deep, indicates that when Hello was released, people started to become interested again in Adele's other songs. On the left, we also provide some metadata like the actual music video that you can play and 2 ways to customize the visualization of the network. One of them is the influence slider that can filter out nodes that have an influence less than the chosen threshold. So as we increase the threshold, the less influential neighbors will begin to disappear. And the drop-down menu provides us with 5 different sorting criteria along the y-axis. By default, the nodes are sorted according to a force-directed algorithm, which tries to minimize the number of crossing edges. But we can also sort the videos by the total view counts, where the most popular videos are placed at the top. Finally, we have a time slider that allows us to progressively reveal a neighbor when it starts to have a significant influence on the ego node. So that was a very quick overview of how AttentionFlow can help us see different kinds of influence on the traffic of rolling in the deep. You can click on the other nodes, or you can use a search bar to visualize the network of other songs. In addition, you can also go to the Vevo artist page to see the influence networks of artists on YouTube, or you can go to the wiki traffic page to see the influence networks of Wikipedia pages. Our demo is live at attention.ml. Please also check out our paper, and we also provide source code for our demo on GitHub. Thanks.